Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this morning will be the finished, what he calls construction of the ATX power supply that I have shown you from a previous, what you call this, long video lecture. So what I did now, since I've got the different color codes which represent one voltage for each color code. So what I did, guys, is that the black lines are actually all ground. So what I did, I merged all the ground terminals, okay, and I placed up the connector at the parent. So just in case we needed a ground connector, we will be needing this portion here. This where we will connect our ground terminal when we are having a DC voltage load. The next color code is actually the yellow. I got two yellows here, two yellow lines. So I merged the two yellow lines and I place at the connector at the far end. So this is where we connect a plus terminal for the first terminal is actually for 12 volts. So just in case we will be connecting a 12 volt load, we connect the ground here on the black thing and we connect the positive terminal on this yellow thing here. And the voltage output of this one is actually 12 volts. We got two lines here which are connected in parallel. Two lines, maybe there are two voltage regulators inside which represent a 12 volt regulator. The next color code here is actually the orange. I got 5 wires here. And the voltage of this orange is actually 3.3 volts. 3.3 volts. So the 5 lines, I merge it into one, and at the far end, I place a connector. So the positive terminal for this voltage here is this one here, the connector at the far end. The next color code will be the red line. I got 4 red lines here. So actually the 4 red lines, I merge it into one, okay, and I connect a connector at the end. So this is where we connect the positive terminal of any load. The last part here, it's a combination of yellow, 2 yellow, and 1 brown. But I checked the voltages. These 2 yellows are 12 volts, and the brown is also 12 volts. So actually we could merge the 3 into 1. So the last part here, it got 2 yellows and brown. I merged them into one, and at the far end, I place a connector. Okay. The main purpose of the connectors is where we connect our loads. Okay. So the first connector here on the far left is actually the ground. The second one is actually the 12 volt terminal of the positive supply. The second one, or the third one, is 3.3 volt, which represents the orange wires. The fourth one is actually the 5 volts, which is represented by the red lines. And the last part is actually because 1, 2, 3, 4. There are actually 5 terminals here. The last terminal is actually the one on the far right. It's a combination of yellow and brown, but all the voltages are 12, so I merged them into one. So this terminal here is the plus 12 volts. Okay. I just placed one indicator LED, and this indicator LED is actually the one on the far end. So I connected the ground of this LED on the ground and the positive terminal on the 12 volts here on the far end. So when this is lighted, the voltage between ground and the far end is actually alive. And so with the other 3, I just didn't place the 3 LEDs anymore. I just placed one. Just to show you that the power supply that we have constructed or assembled is actually alive. The voltage here is alive, and so with the red line, and so with the orange line, and so with the yellow line. I just didn't place the LED on the three connectors. So the one that's lighted here is the 12 volts on the far right. Okay. This power supply is already plugged in. That's why the LED is alive. So meaning to say the voltage now here is available. Okay, it's available. It's actually 12 volts. Okay, let's try to see. Okay, if this voltage here could now be used to power up something. So I brought out my, what you call this, DC electric fan. Okay, the voltage requirement of DC electric fan here is 12 volts. So I will now be connecting the ground of this DC electric fan here on the ground terminal. The one with the color code black. All these black wires represents the ground, and the connector at the end is actually the ground terminal. And I will be connecting the positive terminal of the DC fan on this far right voltage here, the one that's lighted with the LED. Okay, let's try to connect the positive terminal. When I connected the positive terminal, okay, the DC electric fan was alive. It's a strong rotation, meaning to say the current coming out from this one is, it's not big, but it's more than enough to power up this one, because if the current is not so much, okay, the vibration or the murmuring of the rotation of the DC electric fan, you could not hear it, but you could hear it, meaning to say the voltage is okay, the current is okay, so that's why the DC electric fan is working. Okay, so that's the main purpose why I brought out the voltages, the different voltages inside this ATX power supply, because if I needed the voltage, I just could bring it out and I'll just tap in my equipment, and it now works. Like this one here, this electric one here. The ground in this terminal represents 12 volts. So if I will try to remove this one, the DC fan is off. Okay, we'll try to test the first terminal. The first terminal is also 12 volts. First terminal is 12 volts, second is 3.3, third one is 5, and the one on the far right, the one we used a while ago, is actually 12 volts. So again, if I will try to place this one on the first one, which also represents 12 volts, of course the DC fan will still operate. Okay, looking nice, right? So this is 12 volts, the electric fan could be operated. This is 12 volts, the electric fan could also be operated. Okay, I will try to shut off this one on the 12 volt, and let's try to see if this 5 volt could operate this 12 volt electric fan. I know it could operate, but the rotation is not so strong. Okay, I will now connect the positive terminal on the 5 volt source. As you could see, the 12 volt electric fan is working, but since the voltage is less than 12 volts, okay, it's not so strong. There is still a windage that's coming out, okay, but it's not so much. So actually, if these 12 volts and 12 volts are defective, we could use the 5 volts still, and still the DC electric fan is operating. I don't want to use the 3.3. It might overload the circuit for the 3.3. So that's the rotation of the DC fan using the 5 volt source, the one with the color code red. I will remove this one. Okay, again I will try to use the first one, which is a 12 volts, represented by this lighted LED here. And as you can see it, okay, the electric fan is working good. Again, I will try to remove it. I will use the first one because the first one is also 12 volts. And again, the electric fan is still working. Okay, that's it guys. That's the main reason why I brought out the different color code lines, okay, uh, to give me a required voltage for each color code. I will repeat it. The black ones is the ground. The orange one are actually for 12 volts. No, 3.3 volts. The yellow one is actually 12 volts. The red one is 5 volts. And the combination of yellow and brown is also 12 volts. So in here, I got 4 power supplies here, which has more than enough current to power up any gadget or equipment that I will be needing to insert here. The maximum wattage of this ATX power supply is actually 300 watts. So if we are only placing a load which is 100 watts or 50 watts, that's an easy one for this ATX power supply. Because this ATX power supply is actually the power supply of a desktop computer. The maximum wattage of this one is 300 watts. Okay? And I think that's it guys. Good morning from Los Angeles. Okay? This is Professor DBJ de los Reyes, an ATX power supply, which I brought out the terminals. Voltages will be coming out, and if a load is needed, if a load needed the voltage, we just place it here, and it will be working like this DC electric fan. Good morning from Los Angeles, Professor DBJ de los Reyes.